This is one of a series of videos produced by the Further Mathematics Support Programme for A-Level revision. The specification I'm looking at today is AQA D2, and this is question 5 from the January 2011 paper. So the question gives us a network from S to T representing ways of buying internet tickets, or tickets for an event on the internet. And the number on each edge represents a charge in pounds with a negative value representing a discount. So for example, it gives us that the path from S to A to E to I to T, i.e. the one along the top edge, the total is £17. It wants us to work backwards from T in the table which is given on the next page using dynamic programming to find the minimum weight of all the paths from S to T, and then to state the minimum cost of a ticket for the event and the paths corresponding to this minimum cost. So it's a standard sort of dynamic programming sort of problem. Right, so we can see that on the table that we've got the first stage has been done with the values -7, -6 and -5. So what we're going to look now is at the second stage, and the diagram at the bottom left hand corner shows each of the paths that are available to us to go from the nodes E, F, G and H to each of I, J and K. So the state is the nodes that E, F, G and H, and the actions are the possible routes that we can take from those. So we can see that from E then we have the possibility of just going to I, and the value of that is -4. If we go from that particular one to I, then we can pick up the value for I in stage 1, which is -7. So that gives us the -7 plus the -4, giving you a total of -11. So carrying on then, probably the easiest way of doing this is to write in the values that we have at each stage. So we want to put in the from F to I is -3, from F to J is -2. So this is picking off this table or this network here, the values. From G we have 4, 7 or -1, and from H 4. If you now put in the corresponding values from stage 1 for each of these, for I and J, these are -7 and -6. So we're now reading off these values in the table at the top here. I, J and K, -7, -6 and -5, and K, sorry, I beg your pardon, from H to K, and then K gives us a value at -5 at the bottom there. So we're going to have to add all of these together to give us the totals. So I find that that method there is the most efficient way of just reading off from the network and from the values above, not trying to do the addition as you go until the very end. So if we now work out what these values come to, the -11 is already done for us. This is -10, -8, -3, 1, -6 and -1. Now for each of the states that we're in, we want the smallest value. So I'm just going to indicate where the states are. E, obviously there's only one value, so that's the smallest one. F, there are 2 values, so the smallest one is then -10 there. For G there are 3 values, and the smallest one is the -6. And for H only the 1 value, so obviously it must be the smallest. Now, in terms of the marking, actually difficult to explain all the marking for this, but in essence, at this stage there was a mark for basically starting to do this, the B1 mark for getting something correct in this stage. Excuse me. So that's where we're at the moment, and now we're going on to look at stage 3. So the possibilities here, we need to, nothing's filled in for us in this time, so we need to do all of this. So we're at A, and from A we can get to E or G. B, we can get to E or F. C, F, G or H. And D, G or H. So that's just reading off this network here. And again, I would put in the actual values from the network itself first of all. So putting those in, we can see that they are 5 and -2. A little bit tricky to see that on this network in some places. That's the -2 from A to G. And then from B, the values are -2 and -4. From C, they are 6, -3 and -5. And from D, -5 and -3. Now we want to take the values from the table above, again from here, for E, F, G and H, the smallest values. So for the top one we want from E, so that is -11, and for G, the smallest one, -6. So I'm reading off where these arrows are here for E and G. So for E, -11, for G, -6. And then moving down, then we want E and F, so -11, and for F, -10. F, G and H, so that is -10, -6 and -1. And finally G and H, -6 and -1. So again, now we just need to work out these totals by adding these up. And those give us values of -6, -8, -13, -14, -4, -9, -6, -11, and finally -4. And again, we want the smallest values for each of the states. So there's the smallest of the first two there for A, -8, in B, -14. In C, we've got 3 to look at. So the smallest one there is -9, and finally -11 for D. So now we're getting more marks coming in here. A method mark for getting some of these values correct, and an A mark, and also a dependent method mark coming in for these additions here. So another 3 marks picked up at that stage. We're now going to work back one further point. So that's where we're at the moment. And so now we're coming back one further stage, stage 4, where we'll get to S. And from S, we can reach A, B, C, or D. And reading off from the table, the costs there are 23, 28, 25, and 25. And then again, looking at these numbers in the table here. So for A, it's -8. For B, -14. For C, -9. And for D, -11. Giving totals of 15, 14, 16, and 14. So the smallest one here, two of them actually, equal to 14. So 2 more marks there, a method mark and an A mark if you got all of those correct. So that's the actual dynamic programming part done. We now need to look at interpreting. So there's the full table now nicely for us to interpret. It says state the minimum cost of the ticket for the event. Well, we've already decided what that is. The minimum cost is equal to 14, and that comes from the arrows at the bottom here. And now we need to look at the paths corresponding to that. Well, obviously it goes from S. If we follow through the first one here, it's to B, so it's S to B, and then from B to F, the smallest one, so BF. So we're going from, and just try and mark this on the table here. So we're going from S to B, from B to F, it's the smallest one, and then from F it's going to be to I, and then finally from I to T. So S, B, F, I, and T. There's another route which I'll try and indicate in a different colour, going from S firstly to D, and then from D to G, then from G to K, and finally K to -5. So that was K to T. S, D, G, K, and T. There are just 3 marks available for that part of the question. They were simply allocated B1, B1, and B1. Okay, that's the end of this particular question, but you can find solutions to other questions at www.furthermaths.org.uk.